Hi, this is Suey778 coming at you, and today we have yet another multimeter for review, and today's flavor is the Kaiweets HT206D Digital Clamp Multimeter. Now before we get started, I do want to say thanks to Kimberly from Kaiweets for sending this out to the channel for our evaluation and review of this multimeter. So with that, let's get started. This is available at Amazon.com for $47.99 currently, and as of the time of this video, there is a coupon for 20% off. So you can get it for more like around, I don't know, 38, 39 bucks, something like that. So pretty good deal. Anyway, let's go ahead and get to the unboxing here. Nice looking box, I guess. Pretty plain Jane. As you can see, we got the HT206D here. All right, let's open it up. So inside, you get everything inside a included carry case, which is cool. Get that out of the way. And let's get this opened up here. And inside we get a user manual. I'll show you a few specs here if I can find them. This manual's a little bit bent up. Here we go. Try to straighten this out the best I can so you can read them. Okay, and that's it. I guess it was just that one page. Okay, so need to fix that. I kind of unbend that a little bit. Anyway, also you get a set of leads. Fairly standard set of leads. We will test these for continuity later. Also get a Thermaprobe. And you also get a set of batteries, AAAs, PK cells, and last but not least, we get the meter. So there she is in all her glory. Let's get it set up on the table and we'll take a look at it. Okay, and now for an overview of the Kaiweets HT206D. We're going to go from top to bottom. Up here you got your clamps. Over here is the little lever for the clamps. Got your flashlight right here. You got it on the side here. You got a hold/NCV button. Down here you got your rotary selector. You've got your zero out button here. That's for your AC/DC voltage readings. And a max min button, backlight and flashlight controller. And then on the bottom here we have a common jack and an input jack. Standard size. These do work with Probe Masters, so we will be able to test this as normal. Let's go ahead and turn it on. And by the way, a spoiler alert, I went ahead and took the virgin cover off of this one because I was having some issues with that protective cover actually obscuring the display. This display, it's really nice and crisp, straight on, but it tends to wash out at a lot of angles, so I was having some trouble with that, so we had to go ahead and peel that off. Let's go ahead and turn it on. And as you can see, let's go ahead and get that backlight going. Hopefully that'll look okay. And it does. Yeah, it looks nice and clean there. Okay, so we got our 600 amp current range for DC and AC, 60 amp range. Okay, next down is your voltage. Okay, next down is your frequency and duty cycle. Next down on the selector is your diodes, capacitance, continuity, and resistance. Next down is the setting for your Thermaprobe, available in centigrade and Fahrenheit. And last but not least, your low Z. Low Z voltage for AC, and I do believe DC. Let me select it here and see. Yep, get AC on that and DC. Okay, and then basically to engage your hold, you hit your hold there and you see the little hold icon pops up, and then to do your NCV, you just press and hold, and then last but not least, you have to press and hold again to get it out of there, and then you got your little flashlight there. And as you can see, little flashlight. And that's going to be about do it. Let's go ahead and tear this apart and see what's inside. Okay, and before we get to the takedown here, do you want to mention that this is a 6,000 count multimeter, and also it's rated 600 volts for category 3. Maybe, I don't know. I would say at the very least it's a category 2 250 volt. But with that being said, let's go ahead and get to the battery compartment. And we're going to take my new screwdriver here, electric, and I'll probably review this one at some point. Okay, that takes the battery compartment off. As you can see, I've already got a couple batteries in it, and then to actually take this down all the way, there's a screw here and one here. The battery cover screw is brass, as you can see there. These other screws are just tapped in. Okay, got that out. Let's get that out of the way. Take this off. Okay. There we go. It just kind of pops out. Okay, so I've got the PC board propped up here so we can take a closer look at it. You got your two connectors here, split variety, I do believe. The version on this, I can't give you a year on the manufacturer date or the version date, but it is version, let me get my flashlight out again so I can see it. It is HT206B version 1.8, and that's all I can see. All right, no current shunt, no fuses for obvious reasons. All the current measurements are done on the clamp. You've got a speaker here, a pair of PTCs right here. I've got a couple larger resistors right here, some smaller ones down here along with some diodes. I guess that's part of the protection as well. Main processor right here. A pair of spring coils, that's for the battery contacts. Up here, this little green wire you see is probably the NCV antenna. This ribbon here is actually going from probably an inductor up here somewhere down, into that for processing. Got some other smaller microprocessors here. I'm guessing one may control some stuff going on with the clamp. The other, I'm guessing, probably controls the LCD display, although it's kind of in a weird place for that, but whatever. And that's pretty much it. Pretty straightforward, pretty simple. So let's go ahead and put this thing back together and let's do some tests. Okay, and now we're going to test the DC current measuring abilities of this clamp meter. As you can see there, I've got my little HM10 charging up this backup battery. Right now it is sending 7.992 amps through the hot wire here and about 209.2 watts. Okay, so let's go ahead and test and see how accurate this can measure it. So you want to put it on the 60 amp range there, and as you can notice we got a little bit of flutter, so the first thing we're going to need to do is hit that Z/F button to zero that out. Okay, we got that zeroed out. Let's go ahead and measure the red wire, and we are getting 7.93 amps, 7.92 amps. So I would say with that zero function, pretty accurate. Okay, here we go with the AC current test for this clamp meter, obviously using its clamps. What we're going to use here, since I don't have any exposed wires to measure high current, we're just going to simulate it. So I have this little Klein Tools multiplier here. Basically, this will multiply the current reading by 10 times so we can actually simulate high voltage. So we're going to start off, we're going to run it through a space heater. I'm going to start it off just in the fan mode, which should be around 0.17, 0.19 amps. And we'll put it in 60 amp mode here. So let's go ahead and turn the little space heater on. And as you can see there, it is simulating 1.86 amps. So in reality, that's 0.18 amps. All right. So let me turn on the low power for heating. And as you see, we go to over limit, so we're going to have to switch up to 600 amp mode. Interestingly enough, no audible warning. Okay, yep, and that is correct for low power, about 6.15 amps. Of course, this is showing it as 61.5 amps because we're using the multiplier. So that looks good. Let's go ahead and put her up to full power and see what we get. And full power is giving 117.4 amps. In reality, that is 11.72 amps, 11.74. So anyway, as you can see, it works. And let's go on to the next test. Okay, first thing we're going to do here is go ahead and run the continuity test since I've got the stock leads on. So let's do that now. And here we go. We got the stock leads here. Let's go ahead and do this. You know what? These leads are just fine. It's just they got a bunch of oily crap all over them. I can see it. Yeah, these are just fine. So yeah, no problem there. Let's go ahead and put in the probe master leads, because that's what we're going to do the rest of the testing with the rest of the way here. So give me just a second. But yeah, these leads really are not bad. Clean them up with a little bit of 90% rubbing alcohol or denatured alcohol. You'll be good. I like them. They also, I mean, they're made out of PVC, but they're also actually, pretty good. They're fairly, fairly easy to work with. So here we go with the probe masters. Yeah, see, even better. Yeah, no problem. These are good. Okay, here we go with the DC voltage test. I've got my AD584M warmed up and ready to go, so let's go ahead and do this. I've got the UT8804N line with the Kaiweets. So let's see what we get here. We're going to start off with 2.5 volts. Here we go. Okay, 2.5006 for the reference meter, and we're getting 2.497. For the Kaiweets. A little bit low, but pretty close. Not too bad. Let's go to 5 volts. Okay, 5.0055 for the UNI-T. 5 volts even for the Kaiweets. So pretty good there, pretty close. A little bit off, but not by much. Okay, 7.5 volts. And we got our customary 7.502 for the reference meter, and the Kaiweets is reporting 7.49. Okay, so a little bit low. In fact, all of these measurements have been slightly low. And 10 volts. You're getting 10007 for the reference meter as usual, and 9.99 for the Kaiweets. So a little bit low on the voltage measurements, but not bad. Let's go ahead and try 32 volts here. I've got my power supply on the bench warmed up here, so let's go ahead and plug those in and see what we get. Hopefully I can reach over there. And I'm hoping you can see this. I'm not sure whether you're going to be able to see the... I've got a flashlight sitting on the Kaiweets because the backlighting tends to wash things out. I don't know. It's just not very... This particular display is just not very photogenic for whatever reason. It looks fine in person though, believe me. Okay, here's 32 volts. Okay. Yeah, running a little bit high tonight on that power supply. Okay, I've got... 32.021 on the reference meter, and the Kaiweets is reporting 31.98. So again, a little bit low. Not horrible though. So I would say all in all, this is pretty decent. All right, let's go ahead and do some diodes. So first up, we're going to do the LEDs. We've got red with the reading. Okay, good. Yellow with the reading. Green with the reading, and blue with the reading. All right, and white with the reading. All right, let's do the RGB real quick. Here's the red with the reading, green with the reading, and blue with the reading. So flying colors there. Let's move on to the diodes. Here is the rectifier, .545, fast recovery, .508. Okay, good. Schottky, .194. Okay, pretty good there. Switching, .605. All right, good there. And the germanium, .278. Looks pretty good on diodes. All right, let's go ahead and switch over to resistance. And since this does not have a rel feature, we're just going to work off the resistors on the board that I got here. All right, here is 10 ohms. Getting 10.1. Whoops. Yep, 10.2. Okay, we're good. Here's 100 ohms. 100 even. Looks good. 220. 218.9. All right. 330. 329.3. Good. Okay. 1K. .996. .996 mega ohm, I should say. Okay. 2K. .996 K. You know what I mean. I'm an idiot. 2.005 looks good there on 2K. 5.1. 5.117. Okay, good there. Here's 10K. 9.99 looks good. 100K. 100.8 looks good there. These are all pretty much landing almost right on where they should, so that's good. And 1 meg. 10.09. Okay, let's go ahead and measure a few higher ones. Let's get the resistance substitution box out. Do this real quick. Okay, so we're going to go to, trying to get my butterfingers out of the way. Let's go to, as you can see, it's getting there, the 0.3, 0.4 ohm. All right, let's go to 2 meg. 1993, right where it should be. Okay, 4 meg. 3971. Yep, really good, really close. Okay, let's go to 10 meg. 9.98 looks good. All right, let's go to 11 in honor of Nigel Tufnell. If you don't know who Nigel Tufnell is, look it up on the internet. It's a great movie, by the way. And for 11, we get 11. All right, 11, 11, 11. Okay, looks really good on resistance. Absolutely no qualms with this multimeter on resistance. All right, let's switch over to capacitance here. All right, so this is going to be 100 picofarads. Let's see what we get. 96 picofarads, not too shabby. Okay, 150. That's about right, okay. 220, a little bit low, but not that far off, so yeah, that's okay. 330, slightly low, not bad. 470, 474, looks pretty good. 560, this should be a little bit low, and it is. 680, this should be around .64. Yeah, I'd give that a pass. 820, slightly low, but again, this particular capacitor does come in around 780, 800. 1 nanofarad, that's right about where it should be. 1.5, a little bit low as expected. 2.2, slightly high as expected. Yeah, that's okay. 3.3, low as expected. Looks good there. All right, let's switch over to the higher side of this box. Here's 4.7. That's about right. 5.6 should be a little bit low, and it is. 6.8, a little bit low. In fact, that's almost right on there. 8.2, slightly low. Yep, it's usually around right around 8 even, but that's okay. 10 nanofarads, that's about right. 15, a little bit high as expected. 22, pretty much right on. 33, a little bit high as expected. 47, again, high as expected. 56, a little bit low as expected. 68, yep, a little bit low as expected. This is reading a little bit higher than normal, but it's still, well, very reasonably reading these. And 100 should be 102, and we're getting 104. All right, looks good there. Ouch, just stuck myself again. Dummy. All right, let's bring this this back on, and let's do some higher value capacitors. Actually, let's try the 22 puff first. Let's see if it'll read that. I don't think it will, but we'll try it. Nah, yeah, we got a reading. Yeah, 9. That's not good. Oops. Don't do that. Yeah, just 9. Okay, let's try the 85 nanofarad. That's about right on. All right, let's try 1 microfarad. I'd say pretty good there. Again, these are coming in a little bit high, but that's fine. Let's see, 10 nanofarads. Yep, that's just about right. All right, let's try 47 nanofarads, and this should come in around 44-ish. Yeah, 45.75, that's fine. 100 microfarads. $102, a little bit high, but that's good. All right, let's just go to 1,000 here. Should be around 940, 950. It's coming in a little bit high, but that's fine. It is measuring it as lower than 1,000, which it should. Okay, 2200. This should be around 2119, 2120, ideally. Let's see what it does. There we go. This particular capacitor has always been a bit stubborn. Okay, 21.55, a little bit higher than what I expected, but yeah, that's just fine. All right, let's move on to the big one. See what we get on this guy. Taking its sweet old time, but yep. Yeah, this should come in between 950 to 975, and it's coming in, I should say 9.5 to 9.75 millifarads. This is coming in at 9.866. That's fine. Okay. Pretty good on capacitance. Tends to measure a little bit high and does get slow. Okay, let's go ahead and do the output. Forgot to do that earlier. So let's do the output on the diodes. Let's see what we get. Let me put it in diode mode. There we go. So we'll just use the UT8804N this time. Since it is my reference meter, might as well. And pretty healthy 3.2786 volts. Very good. All right, so that pretty much light up anything. Okay, now we're going to go ahead and go with the NCV test. So let's go ahead and do this. Okay, picking it up. Interesting that when you turn it sideways. Okay. All right, let's try the laser light up above. Good there. I'd say it's relatively sensitive. Okay, now on to the frequency test. Now, according to the manual, this has a range from 10 hertz up to 10 kilohertz. So we're going to see how far it can go below and above. We're going to start it off with 1 hertz, so let's go ahead and get her started. And I'm running an amplitude of 2.5 volts, amplitude voltage. Okay, we're getting a 0.999 hertz. Okay, let's move up to 10 hertz. $9.998999. Okay, looks good to me. Oh, let's check. Let's toggle for duty cycle here. I'm going to check this a couple times. Okay, 50.3, so we look good there. All right, let's go to 100 hertz. 99.99. Okay, looks good there. Let's go up to 1K. Again, 999.9 hertz. All right, looks good there. Let's go to 10K. And again, 9.999. All right. Let's go to 100K here. And again, 99.99 kilohertz. All right. Interesting. Likes to display those nines, doesn't it? All right, let's go to 1 meg. And we are getting 999.9 megahertz. Should have guessed right. All right, let's go to 5 meg. 4.999 megahertz. Okay, let's go up to 10. 9.999. Well, here's the moment of truth. Let's see if... all right, let's just go ahead and try to run it right up to 20. And it is reading 20. How about that? All right, let's check the duty cycle here. Remember, we're using a sine wave. We're not using a square wave here. I always test with a sine wave. Duty cycle is, it's all right. It's okay. 50, about 55. All right, but 20. So that's already 10 megahertz above its spec and at 2.5 volts amplitude. So not too bad. Let's try 25. Nope, didn't like that, did it? All right, let me push the amplitude up to 5. And we'll try it again. Okay, there's 21. Good. Make sure my arm isn't blocking. Okay. 22. Good. All right, let's try 25. Good. 30. Nope, lost it again. Okay, we get 26. 27. Okay. Looks like we lose it between 27 and 28 megahertz, but really, really good on this frequency test. Its maximum is supposedly 10 megahertz. we got it to go up to 27. So really good deal on that. Okay, last but not least, the thermoprobes. So as you can see, I got those plugged in. We are at 24 Celsius. Let me switch over to Fahrenheit. 75 Fahrenheit, looks good. All right, let's try it with body heat. Reacts, not too bad. Yep, jumped up to 92. Yep, 93. All right. Well, you know what's coming. We're going to do the fire test. So let's get that in there. Just want to make sure that we can see it and that it's visible. Oh yeah, no problem. Thermal probes are good. Yeah, it jumped up to 400 degrees there. Ooh. And there you go. All right, let's go on to the pros and the cons and the conclusions. Okay, and now for the pros and the cons. First to the pros. This meter has good accuracy on all measurements, pretty much across the board. The HT206D was quite impressive that way. Also, another pro is that it is easy to use, quite easy to use. I almost didn't have to look at the manual to operate this thing, and that's always a plus in my book. Speaking of the manual, it is a legible, well-written manual. No complaints with that, other than the fact that it was folded up and kind of funky out of the box, but other than that, no big deal. Even though it doesn't really show it on camera, this is a good display with good backlighting, and it looks very sharp to the naked eye. Just for whatever reason, this is just one of those LCD displays that is not very photogenic. But in person, trust me, it looks good. It washes out at some angles, but for whatever reason, it washes out a lot more with cameras, at least my camera. So it could be my camera's the problem, I don't know. The clamp measures both AC and DC current, and it is reasonably accurate. Didn't have much to complain about with that. Looked pretty good, especially on AC. On DC, it was pretty good too, although when we were doing our DC current test, basically I was comparing this meter, to what the power supply was saying that it was pumping in, and my guess is it was probably somewhere in the middle. But either way, there wasn't that much of a difference. They generally agreed on where the current was. So good on Kaiweets for that. Also, a very decent count resolution. I like this 6,000 count clamp meter a lot better than the HT200B's 2,000 count resolution. It's just a lot easier to work with. And last but not least, it comes with quite decent stock leads. I was pleasantly surprised, and like the HT200B's stock leads, the HT206D's leads were also equally good. Usable right out of the box, and I have no complaints. Easy to work with too. Okay, and now on to the cons. The HT206D is somewhat slow on higher value capacitance readings and also tends to read them a little bit high. Not a big deal, but just something to know. The display only stays backlit for 20 seconds, which is a little bit of a bummer. It would have been nice if it had stayed on. That's just my preference, but at least you have a backlight to work with. So that's a minor complaint. Also tends to measure voltages a little bit low. I've noticed that with this meter, especially on DC voltage. It's not so much AC voltage we're talking about, that's DC voltage. It's a little bit low. But it's not bad and it's not off by much, and you still pretty much can get a general idea of what you're doing. But if you're more into precision stuff, then yeah, this might not be the best choice. The other con that I would say that this has is in current mode, it has no microamp or milliamp range, and in voltage mode, it has no millivolt range. So this is not a true electronics, bench multimeter, but it comes pretty close. Okay, and now on to the conclusion. The Kaiweets HT206D offers a lot of versatility for a clamp meter in the sense that it has a full set of features and will measure both AC and DC current on its clamps. This would also be a good choice for an electrician who needs to measure higher currents than what would typically be found on an electronics bench. This is also a good choice as an all-around household meter. It would not be that great of a choice for an electronics bench, since this meter has no dedicated microamp or milliamp ranging and no millivolt ranging, but it can still be used in a pinch. And overall, the HT206D is a very solid clamp meter, and I definitely give it a thumbs up. Definite thumbs up. I like this meter a lot, and once again, I do want to say thanks to Kimberly from Kaiweets for sending this out to the channel for us to review. Thank you very much. Sorry it took me so long to get to it, but we did get to it. Anyway, until the next time, we'll see you on the flip side. Thanks for watching. So this is not a true electronics, bench multimeter, but it comes pretty close. Almost there. I'm just waiting for the fucking car to drive by. Come on, get out of here, buddy. I'm trying to finish the video here, goddammit.